Okay, in the previous class, we have seen types of loading that is applied uh, on the bridges. So quickly, we will revise what we have seen in the previous class. So basically, you have the loading is given in IRC 6 2017. Here I have written 2014, but it has been revised in 2017. So we need to use the latest code. That is IRC 6 2017. So I told you we have IRC different types of loading that is applied on the bridges. IRC class AA loading, IRC class 70R loading, IRC class A loading, IRC class B loading. Okay, and you also have special vehicle loading, but that is not in the syllabus. These are there in the syllabus. IRC class A loading, again it is divided into tracked vehicle and wheeled vehicle. We have seen this in the previous class. Tracked vehicle is simulating an army tank of 700 kilometer, and wheeled vehicle is simulating an heavy duty army truck of 400 kilometer. So this is how the tracked vehicle will be. You have two tracks and you have some contact distance to the road. Okay, so this is how the track will be. For IRC class AA tracked vehicle, the contact distance is 3.6 meter. The total distance of the vehicle is 7.2 meter. The load is 700 kilonewton, and you have two tracks in the in the vehicle. So the load of each track is 350 kilonewton, and the width of each track is 0.85 meter, and the distance between the clear distance between track is 1.2 meter. Okay, this is the longitudinal section, and the thing that is there on the right side, it is the cross section of the tank. Okay. I will talk about clearance in my this lecture, but quickly we will revise. Okay, so we have seen the loading. Okay, class 70R loading again. It is divided into tracked vehicle and wheeled vehicle. So all this loading is there in IRC 6. IRC 6 is allowed in the exam, and you should know how to refer IRC 6 that you will be learning in this subject. IRC class 70R tracked vehicle, the load is same. It is 700 kilonewton. It is same as class AA tracked vehicle. Okay. The tracked vehicle is somewhat similar to that of class AA tracked vehicle, but the contact length is different and the overall length of the vehicle is different. The length of the track is 4.87 and the overall length of the vehicle is 7.92 meter. Okay. And the width is different here. Width is 0.84 and the clear distance between the track is 1.22 meter. This is about 70 track vehicle. Class AA loading, I told you, it consists of n number of wheels, and different wheels they have different load. If you see the cross section, you will able to see the width of the tire and also the contact length of the tire. So you see the contact length of the tire with the road is B and the width of the tire is W. So different width and contact distance will be there for different loading. 114 will have different contact length and different width. Similarly, depending upon the loading, you have different dimensions of the tire. So we have seen this also in the previous class. Class B loading, the loading is same, Loading means the pattern is same, but the magnitude of the loading is different. The pattern is same. Okay. So this is about loading that we have seen in the previous class. Components of the bridges, you will see that in this class. See the component of the bridges. The main part of the bridges are decking, consist of deck slab, girders, means there are beams in the bridges. Those beams are known as longitudinal girders and cross girders. You also have trusses in some bridges. Bearing for decking. You see this image? So here we have a pier, okay, and this one is known as abutment. And abutment is also having the wing wall, okay. This is the railing that we provide, and this is the beam. This is known as longitudinal girder, okay. Okay, so we also have foundation for abutment and piers, approaches to the bridge to connect bridge proper to the road on either side. Here you can clearly see what are the cross girders. So these are the cross girders and these are the longitudinal girders. Such bridges are known as T-beam bridges. T-beam bridges. In the T-beam bridges, you will have the slab, and below the slab you will have the longitudinal girders, and and the cross you will have the cross girders. Okay, this is how the bridge will look. Here you can see the bearing between the pier and the deck. Bearing is there. Bearing is provided no, to transfer the load from the deck to the pier. Okay, here something will be very clear about the dimensions of the bridges, how the bridges will look like. Components of the bridges. This is abutment, and this is longitudinal girder, and between the longitudinal girder and the abutment is bearing. We are providing bearing. This is another pier, and above the longitudinal girder you have the handrail. This is known as approach road. Okay, and you have the deck slab and the cross girder. Cross girder beam will look like this, and this is the deck slab here. Okay, so this is how the bridge will look. This is the dimensions of the bridge. Okay, okay. So now we will see what is there in the next part. Okay, again you will see the components of the bridges. You will only see the superstructures. See the components of the bridges above the bearing is known as superstructures, and the components of the bridges below the bearings is known as substructures. So in the substructures, you have the pier of the bridge, and you have the abutment of the bridge. Then foundation is also there.
तो स्क्रीन में
So
कुछ
that
विजिबल
comes
नहीं है.
visible नहीं है. Okay. Now is it visible? Let me know screen is visible or not.
हाँ सर विजिबल है.
Okay. So in the components of the bridges, you have superstructure, superstructure, and substructure. So superstructures are those components which are above the bearing, above the bearing. Like you have longitudinal girder, you have cross girders, you have deck slab. So all the components of the bridges which is above the bearing are termed as superstructures. So in this subject, we will see the design of the superstructure. We will see the design of the deck slab. We will see the design of longitudinal girders, cross girders. So basically, we will look at the design of superstructures. We will also look at the analysis of the substructures, not the design, but analysis of the substructures. But here we need to understand what comes in the substructure. So whatever structures of the bridge that is below bearing, including the bearing itself, the bearing will also come in substructure, the piers and the abatement. Abatement. The foundation will also come in the substructure, foundation of the bridge. Okay, so these components will be termed as substructures. In our syllabus, we will be looking at the analysis of the abatements, analysis of the pier. We will also look at the analysis of the bearing that is there in our syllabus, but foundation is not in our syllabus. We will not look at the foundation. Okay. Okay. Can anyone tell me what is the difference between abatement and pier? Can any one of you tell me what is the difference between pier and abatement? Anyone? Abdullah? Okay, abatement is the last pier. So this is the bridge that you have, and it will have the n number of support. So whatever the intermediate support that you have, the intermediate support, those are known as pier. And the end support, the support at the end, are known as abutment. Okay, so this is the difference between abutment and pier. Okay, so we will see the cross section of the bridge, cross section of the bridge, how the bridge will look like, and what are the different components in the cross section of the bridge. So this is how the bridge will look like. You have the longitudinal girder like this. These are the longitudinal girders. Okay, so this is where the vehicle will run. From here to here, it is known as carriageway. This is the actual road on which the vehicle will move, and that distance is known as carriageway. Carriageway width. You can call it as carriageway or you can call it as carriageway width. Both are same. Okay, so above this, you are providing wearing code. The number, the tar that you provide, that is known as wearing code. You are providing wearing code that is of 80 mm or 100 mm. This is wearing coat. It is of 80 mm or 100 mm. Okay, wearing coat. 80 mm wearing coat. Then this is known as deck slab. This is deck slab or RC slab. Simply you can call it RC slab. These are known as the longitudinal girders. Longitudinal girders. If you are providing T bridges, then you need to provide the longitudinal girders as well as the cross girders. Cross girders will look like this. Here, longitudinal girder. Basically, the width of the carriageway normally it is 7.5 meter. Normally, it can be less than that, and it can also be more than that. But normally, it is 7.5 meter. Then here you have the footpath, which is also known as curb or footpath. So this distance normally it is 600 mm. It can also be 1 meter. Okay. Here I am showing it as 600 mm. Then this depth is 300 mm, the depth of the footpath, how much height of the footpath that we have provided from from the deck of the slab to top of the footpath. The width of the longitudinal girder normally it is 300 mm. 300 mm. Okay. And center to center distance between the girders it can be 2.5 meters. Okay, so this is the details of the cross sections of the bridge. Okay, this is the detail of the cross section of the bridge. Cross section of bridge deck. Okay, so any question you have, class? This part is clear? Abdullah?
Yes, sir.
Okay. Now we will see the clearance. So I have told you, this is how the bridge will be. Okay, and here you will put the vehicle. So I'm putting. Okay, we will see the clearance. Clearance. What is clearance? I will tell you. So first we will see the clearance of, for class 70R tracked vehicle. Tracked vehicle. So where we have to put the vehicle, where we have to put the loading. So in the tracked vehicle, two tracks are there. So one track you can put here like this. The other track you can put here like this. Okay. For 70R, the width of the track is 0.84. This is also 0.84. And the total distance, total width is 2.9. And the distance between the track is, I think it is 1.2. Okay. Now, what is clearance? Clearance means the distance from the footpath of the track, distance of the vehicle from the track, or you can call it as distance from the road face of the curb. This is also known as curb, road face of the curb to the outer edge of the wheel or the track. This distance is known as clearance. Okay, this distance is known as clearance. So basically for 70R tracked vehicle, okay, and also for class AA tracked vehicle, this clearance is 1.2 meter. Okay, this clearance is 1.2 meter. One more thing you need to see here. One more thing you need to see. 70R tracked vehicle and class AA tracked vehicle is only provided in the bridge when the width of the bridge is 5.3 and above. When the width of the carriageway, this is known as carriageway. Okay, I told you what is carriageway. When the width of the carriageway is 5.3 and above, then and only you can put 70R loading. Then and only you can put class AA tracked vehicle loading. If the carriageway width is less than 5.3, then tracked vehicle is not applicable. You cannot put tracked vehicle load on the bridge. Okay, so tracked vehicle, 70R tracked vehicle and class AA tracked vehicle is only applicable when the carriageway width is 5.3 and above. Okay, this is about tracked vehicle. We will see about class A train of wheels. Second, we are seeing the clearance. We have seen for the tracked vehicle. We will see for class A loading. Class A loading, which is also applicable for class B loading. This is clearance. We are seeing the clearance. What is clearance? The clear distance between the road face of the curb and the outer edge of the wheel or vehicle. Okay, so in the class A loading, this is the bridge that you have, and this is the width of the carriageway. Okay, width of the carriageway. So how you will put the load? So normally you will put two class A loading, one this side, one here. Okay, this is one vehicle of class A loading, one vehicle of class A loading. You will able to see two tires of it, and another vehicle you will show here. This is another vehicle of class A loading. Okay, and this distance F is the minimum clearance between outer edge of the wheel and face of the curve. And this distance is G. G is minimum clearance between the outer edges of the crossing vehicle. So this vehicle is crossing, this vehicle is also crossing. So G is the minimum clearance between the outer edges of the vehicle, okay? Crossing vehicle. Again, this is F. What is F? F is the minimum clearance between outer edge of wheel and face of the curve. This is outer edge of the wheel and this is face of the curve. Okay. So G and F, it depends on the width of the carriageway. I will tell you. So all this data is given in IRC 6. IRC 6 2017. You can refer there. Don't have to remember. But you try to understand what it is. Clear, clear carriageway width. Clear carriageway width. Okay. If it is between 5.3 meter to 6.1 meter, then G will vary from zero point 0.4 meter to 1.2. What is G? The minimum clearance between the crossing vehicle. And F, I will tell you what is the value of F. If it is above, if the width of the carriageway is above 6.1 meter, then G is 1.2 meter. And F, for all the width of carriageway, F will be 150 mm for all carriageway width. For all carriageway width. Okay, so this is, we have seen the clearance. What is clearance? Clearance is F here, and F is 150 mm. For class A loading, it's also applicable for class B loading. Clearance in the track vehicle, we have seen the clearance in the track vehicle is 1.2 meter for 70R track vehicle and class AA track vehicle. So we have seen clearance for uh, two main loading. One is track loading and other is wheel loading. Wheel loading means that is class A loading. You got this? Any question, class? If you have any question, you can ask. Or shall I proceed? Any question? Oh, okay. Now we'll see nose to tail distance. We will see nose to tail distance. Nose to tail distance. Nose to tail distance. So in case of 70R tracked vehicle, 70R tracked vehicle, and also class AA tracked vehicle, tracked vehicle, the nose to tail distance is same. If this is the bridge that you have, and this is one track that you're putting, this is your one track, okay? This is one track, and this is another track. So this is known as nose of track, nose of track, and this is known as tail of track, tail of track. So the nose to tail distance between them should be, when you're putting the load on the bridge, you cannot put load, one after another track. You have to have some distance between the track. So that distance will be 90 meter in case of tracked vehicles. Okay, the distance, the contact distance of the track is 4.57 in 70 hours, and that is different in class AA tracked vehicle. Okay, the contact length is different. The only difference that we have between the 70R and the class AA track vehicle is the contact distance. Okay, so this is what we have learned, nose to tail distance. In case of wheeled vehicles, 70R wheeled vehicle and class AA wheeled vehicle, this distance is different. Okay, in case of 70R wheeled vehicle and class AA wheeled vehicle, class AA wheeled vehicle. If this is your bridge, so one track you're putting here, one track of wheeled loading you're putting here, another you have to put here. The distance between them should be 30 meters. Random you cannot put it. You have to maintain this distance. This is given by IS code, IRC code. So the minimum distance should be 30 meters between two wheeled vehicles. Okay. Next we have combination of live loads. Combination of live loads. In the bridges, you have different number of lanes. So how the lanes are decided? Lanes are decided based on the width of the carriageway. So we will see here for different width of carriageway, how to put the load and how many number of lanes we are about to get. Based on that, you will have different combination of live loads. We have seen live loads, that is class AA, track vehicle, class AA wheeled vehicle, then 70R, tracked vehicle and wheeled vehicle, then class A loading, and we have also seen class B loading. Okay, class B loading is only applicable to the temporary bridges, to the very small bridges. It's not applicable for the highway bridges. Okay. So we will see how to put those loads depending upon the width of the carriageway. And depending upon the width of the carriageway, you will also provide number of lanes. So here serial number, then carriageway width. So all this data is given in IRC 6, carriageway width. Then number of lanes, number of lanes. जिन्हें मस्ती जस्ट नीचे रहेंगे फिल्म लैब में नहीं ना वो ऊपर उसको बुलाए ठीक है हम then you have the load combination. Okay, if the carriageway width is less than 5.3 meter, okay, if it is less than 5.3 meter, you only have to provide one lane. And in the one lane, what load you will put, I will tell you here, the load combination. The width of the carriageway is less than 5.3 meter. And in that case, you only have to provide one lane. In the one lane, the loading will be like this. One lane of class A loading. Class A loading considered to occupy 2.3 meter, and the remaining width of carriageway shall be loaded with, and the remaining width of carriageway shall be loaded with shall be loaded with 500 kg per meter square. Okay, I will give you the diagram and that will be very clear. This is how the bridge is. This is your bridge, the cross section of the bridge. This is the footpath that you have on either side. And this width of the carriageway is less than 5.3 meter. Less than 5.3 meter. So in that case, how you are putting the load? So here you will put one lane of class A, only one vehicle of class A. And we have seen this, the clearance, this is 150 mm. Okay. The width of the tire, we will see that center distance is 1.8 meter. So this is how you will put the load. The class A loading you will put like this. This is class A loading. Okay. And the remaining width of the carriageway shall be loaded with 500 kg per meter cube per meter square. 500 kg per meter square. So this is how the loading will be when the carriageway is less than 5.3 meter. You will put the one lane of the class A loading, one lane of the class A loading with some clearance, and the remaining width of the carriageway shall be loaded with 500 kg per meter square. You got this, class?
Yes, sir.
Okay, if you have any question, you can ask. It will take some time to understand, but once you understand, you will able to solve the problems. Okay, this part is very easy, but it will take some time. This is new for you. Okay,
सर ये 2.3 मीटर कहाँ से आया? अपना व्हीकल का वो व्हील बेस तो 1.8 मीटर ही है ना?
ये पूरा जो है ना, ये पूरा 2.3 हो जाएगा। व्हीकल ये 0.5 है। ये जो टायर का विड्थ है ना, मैक्सिमम टायर का विड्थ 0.5 है। तो टोटल ये 2.3 हो जाएगा। ठीक है, नहीं आया समझ में? अब्दुल्ला।
तो जो वन
हेलो।
पॉइंट एट है वो व्हील के सेंटर से लेके वो सेकंड व्हील के सेंटर तक का है क्या?
हाँ, 1.8 सेंटर टू सेंटर डिस्टेंस।
व्हील के सेंटर ना, और पॉइंट फाइव
हाँ।
पॉइंट फाइव का व्हील है तो अपन 0.5/2 ऐड करेंगे उसमें, तो टू
हाँ
पॉइंट थ्री
हाँ,
होगा।
2.3 हो जाएगा ये, ठीक है।
ठीक है सर। और सर उस साइड पे कुछ नहीं लेंगे अपन, जो दूसरा साइड है, जो एफ वाला
दूसरा
साइड
साइड
बोल रहे थे आप?
में सिर्फ ये 500 kg पर मीटर स्क्वायर ये अप्लाई करेंगे।
एफ वाला जो है वन